Today we are going to talk about part 5 loop constructs of Java OCA exam 1Z0-808. So previous chapter was arrays and we have already uploaded those videos in YouTube. You can have a look. In the current chapter 5.1 we are going to talk about while, do while and for loops, and you are here. Okay. So why loops exist and how Java evaluates them, that's the topic of this particular slide. So Java provides 3 traditional looping constructs: while, do while and for. The key difference between them is when the loop condition is evaluated, right? The while loop checks the condition before the loop body executes. If the condition is false at the very beginning, the body never runs at all. So the minimum number of executions for a while loop is 0. The do while loop works totally differently. The body runs first and the condition is checked afterward. Because of this, the loop always executes at least once, even if the condition is false. The for loop also checks the condition before each iteration, similar to a while loop. However, it places the initialization, condition and update together in the loop header. This makes the for loop the most natural choice when you know the exact number of iterations. Java also provides an enhanced for loop, which we are going to discuss in detail. It's sometimes called the for each loop. This loop is designed specifically for iterating over arrays or collections when you simply want to read each element. Okay. The syntax looks like this: for int n colon array name. It means that for each element in the array, assign it to the variable n. Unlike the traditional for loop, the enhanced for loop does not expose an index. Because of that, it is very simple. It's simpler and cleaner, but also it is very less flexible. That we have to keep in mind for the exam. You cannot modify the array elements through the loop variable, and you cannot access positions or skip based on index. So the enhanced for loop is best used for read-only iteration, when you just want to process every element in the collection or array. So understanding when the condition is checked is important for the exam, because many questions test what happens when the initial condition starts out false. So that we have to remember. Okay. So next slide is anatomy of a Java while loop. So in the while loop, you handle the initialization before the loop even starts, and then the condition acts like a gatekeeper checking if it's okay to run the code inside. You are responsible for the update inside the loop's body. If you forget to change your variable there, you will end up stuck in an infinite loop. We have to remember this. Okay. So if you see this particular code, right, int I equal to 0, that's the initialization, and while I is less than 5, right? So you are checking, but I is 0 now, so it goes into the body of the loop. So you do a system out.println loop number, I is still 0 and I plus plus. So we keep doing that, and once it is still like 4, the while loop will execute. After that it will exit, right, when I becomes 5. You have to remember that. That's the update part. So in example 1, if you see, it's a normal while loop. Counter increment still is less than 5, right? The while loop brace trap is a very common pattern, and it behaves the same way as the if statement brace trap that we discussed earlier, right? When curly braces are omitted, as in example 2, only the very next statement belongs to the loop body. Any statements that follow are outside the loop, even if they appear indented as if they were part of it. So in this example, if you see total is the only statement executed inside the loop. Okay, total minus minus is the only statement that is executed inside the loop, because if you see that while counter less than 15, right, after that there is no curly brace. So obviously the next statement is total minus minus, so that will be executed. That's inside the loop. The statement that is counter plus plus is outside the loop and therefore runs only once after the loop finishes. Because counter never changes inside the loop, the condition counter less than 15 always remains true. So as a result, the loop never terminates, creating an infinite loop at runtime, even though code compiles without errors. So in exam questions, you may be shown code without braces and asked either what the output will be or how many times the loop executes, etc. To answer correctly, you must carefully identify which statement is actually inside the loop body. Okay, and if you see in this while loop, right, so it's while counter less than 15, total minus minus. So counter is outside the loop, right? So counter never changes. So counter never changes. So it's an infinite loop at runtime, okay? Because counter plus plus is not within the loop. Counter always stays within the loop. Next slide is do while loop guaranteed fast execution and scope trap. The do while loop guarantees that the loop body executes at least once, okay? So this happens because the condition is evaluated after the body runs. Even if the condition is false and false the first time it is checked, the body has already executed once. So there are two important syntax details that are often tested in exams. First, the semicolon after the while condition is mandatory. Now, the syntax ends with a while condition colon, semicolon. This is unique to the do while loop, and forgetting the semicolon results in a compile time error. So we have to remember that. Second, there is a scope related trap. Any variable that is declared inside the do block is limited to that block scope only. This means the variable cannot be accessed in the while condition that follows. For example, if you declare int result inside the do block and then try to use result in the while condition, the code will produce a compile time error. The correct approach is to declare the variable before the do block. This way, the variable is in scope for both the loop body and the condition. Okay. So next slide is for loop, structured, optional paths, and multiple variables. The for loop has three components in its header: initialization, condition, and update. So initialization, condition, and update. Think of the for loop as a compact version of the while loop we just talked about, where everything you need is packed right into one line. You start with the initialization to set your starting point. The condition tells the loop exactly when to stop, and the update changes your variable after every single round. However, all three parts are optional. For example, writing for if you say write for then colon colon semicolon semicolon with all sections empty in the for loop, that will create a valid infinite loop. The initialization section can declare multiple variables as long as they are of the same type. For instance, you can write in initialization int I equal to 0, comma j equal to 10, and that will be valid. And both variables can be used throughout the loop. However, what you cannot do, you cannot mix different types in the same declarations. Writing something like int I equal to 0 and long j equal to 10 in the same initialization section, it will result into a compiler time error. The update section can also contain multiple expressions separated by commas, like for example I plus plus then j minus minus increments I and decrements j during each iteration. So there is also an important scope rule to remember. If a variable declared in the for loop header, it is accessible only within the for loop. Once the loop finishes, the variable goes out of scope. Trying to access that variable after the loop ends will result in a compile time error. Okay, so we have to remember all that. For loop variable shadowing trap, right? That's an example we have given there. So this example illustrates a common exam trap that combines two concepts: variable scope and variable shadowing. The class defines a static variable named counter with an initial value of 4. Inside the for loop, a local variable with the same name counter is declared and initialized to 5. Within the loop, any reference to counter refers to the local variable, not the static one. The local variable shadows the class level variable during the execution of the loop. So when the for loop finishes, the local variable goes out of scope and no longer exists. At that point, the name counter again refers to the static class variable which has never been modified and still holds the value 4. The print statement therefore outputs 4 and the post decrement operator that reduces the static variable's value to 3. The key idea is that a local variable can shadow a class level variable and the two variables operate independently of each other. Okay? Loop comparison, choosing the right one. So choosing between three loop types is often a design decision, right? But the exam questions may also ask which loop is most appropriate for a given situation. So you always use a while loop when the number of iterations is not known in advance. The loop continues as long as certain conditions remain true. Use a do while loop when the loop body must execute at least once, because the condition is checked after the first iteration. A common example is prompting a user for input before validating it. So, and use a for loop when you know the exact number of iterations ahead of time. The initialization, condition, and update are all placed together in the loop header, making the loop structure very clear and compact. So let's come to the practice question part. So we have a class here and we have a do while loop here. So question is, what is the result, right? So the do while loop, we see int y is equal to x into 2, then x plus plus, and then while y less than 0. Okay, so here the answer is C. Y is declared inside the do block, so its scope ends at the closing brace. Okay, so the while condition references y, which is out of scope at that point. This is the do while scope trap. So the answer is C. So the compilation error will happen at line A, because you see y is declared within the do loop and it's not visible outside the braces. Okay. So thanks for your time. You can practice many questions, 1624 questions at javalearn.classtomito.com. There are 29 full day practice tests there, and there are timed exams.